Hello, thanks for joining today. My name's Luke Smallwood and I'm joined by Nick Furness. And today we're going to talk to you about optimizing your data workflows for working offline with ArcGIS Runtime. This is the third session in a series we're running about working with offline data. We've also looked at working with your maps online and offline, editing your data online and offline. And in today's session, really what we're going to focus on is some of the best practice we want to share with you for working with offline data. These are some topics that have come up in conversations with customers, and we want to share them with you today because they can be useful whether you're starting out with offline workflows in Runtime and you're thinking about your first app, or even if you've been working with Runtime for a while. There will be some information in here that's useful to help you really optimize and understand the best way to make the most out of this kind of workflow in the Runtime. So the agenda for today is going to cover a few areas. We're going to begin by looking at how you can optimize the data itself. We'll talk about working with version data. We'll talk about the different strategies that you can consider when using the sync framework. We'll talk a little bit about data encryption and some other considerations that you would want to take into account when you're working with offline data. So in this first section, I'm going to focus on how we can optimize the data itself. The real challenge when working with offline workflows is how do we deliver the data to the device? That can be a bottleneck in terms of large downloads that we have to have time and network bandwidth for. And it can also very quickly fill up storage on smaller devices. There are several approaches that you can consider to help you achieve the best optimized workflow in terms of your data. The first place to start is right back when you set up the data itself. So when you're designing your map, or your layer, or even the underlying data set, it's important to think about what you can do to ensure the data is really appropriate for offline use. There's also different options you can use with the tools that are available within the Esri system about how you create that data and how you access it. And finally, we're going to look at some options within the Runtime API that give you different ways of working with the data and allow you to make some choices that best meet the workflow that you're targeting. In terms of map and layer design, which is, as I mentioned, is the best place to start, the kind of overriding message is just because it's easy, it doesn't mean it's right. Now, by that, I mean it's very easy to set up a web map, add all of the layers that you're interested in, enable it for offline, and then you simply take it offline with the Runtime API, and it will work. The system absolutely supports that, and there's nothing wrong with that workflow. But you may be doing unnecessary work each time you take a map offline, and it's not necessarily the optimal approach. You really have to drill down into what data is absolutely required in your workflows. So you can start to think about some of your data as maybe contextual information. Some of it's maybe business data that you really need to have access to the underlying data itself. You can think about the currency of your data. So how often does your data update? If it changes very frequently and you need to have those updates, then that's something you're going to have to be able to sync up on your device. But on the other hand, if the data changes very infrequently, maybe it's something that you don't need to update on the offline map regularly. Maybe it's something that could be added to a base map layer. So for example, you could create a vector tile layer and include that data in your offline map as a vector tile package. Maybe it could even be done ahead of time, so it doesn't form part of the payload when you take the map offline. In terms of the feature data that's in your map, it's also worth thinking whether everything needs to be identifiable and whether everything needs to be editable. In some workflows, certain features wouldn't be required to be edited or identified, and in that case, you could consider the option that these could be added to a vector tile layer or maybe a map image layer, and that can greatly reduce the overhead of creating a geodatabase and syncing these features. So there's all kinds of options about exactly how you're going to include the data in your web map when you take it offline. And the last point that I want to raise here is think about whether the data can remain online. For some types of data, it's possible to see them as useful supporting information, but not critical to your workflow. So, for example, we might consider that we have a really wide area base map, maybe one of the ArcGIS Online base maps, that's useful for context, but all we really critically need for the offline work is a smaller area that has to be on the device. What you could consider doing there is leaving an online base map to be used when available, and that could remain part of the web map. When network's not available, we'll always have the local tiles on the device to fall back on. The same could be useful for supporting information like weather or traffic. That data, first of all, is rapidly changing, so it wouldn't maybe make sense to try and take it offline. But also, it can be left online so that when it's available, when you have a network connection, you get useful information. When it's not there, there'll be no data in that layer, but the workflows are still possible. So one of the first things you can think about when setting up your web map to be taken offline is basemaps by reference. And this is a workflow that's supported whether you're using a pre-planned or an on-demand workflow. So that's whether the web map is pre-configured with a set of map areas that were generated ahead of time, or whether you're asking your end users to take an area offline on demand each time they want to take an offline map. And how this works is that the web map author sets up their map, and in the offline settings section, they can supply the name of a local basemap file. That could be TPK or TPKX or VTPK. And we're expecting devices to have that basemap file available. Runtime is able to detect that basemap file name, and if it's present on the device, we don't need to take it offline again. That means if the basemap has been sideloaded to my device, maybe as part of my organization's deployment, then when I come to take maps offline in my study area, if the basemap's already present on the device, we don't have to download any new data. We can simply use the basemap that's already on the device. So by sideloading those basemaps ahead of time, we can go on to use the local file instead of downloading a fresh basemap each time. And you can see in the diagram here, you could use the same basemap for many different offline maps. Let's say a lot of your work focuses on a single city. If you can prepare your devices with basemap for that city ahead of time, you can simply use that whenever you need to work offline in that area. And that can be a really powerful way of reducing the amount of data that you download each time. So that reduces the footprint of the offline map on the device, but it also speeds up the process of taking data offline. I'm going to hand you over to Nick now for our first demonstration of today, where he's going to look at using basemaps by reference.
So basemaps by reference allow you to take a web map offline without pulling the basemap down. If, for example, you have a local basemap, a tile package or a vector tile package already on the device that you want to make use of. This is useful, for example, where you have field workers with a large coverage area and they jump around day to day from part of the area to another part of the area, and you can just install a single basemap that will always cover them, and they just pull their operational data down whenever they need it. So it begins by configuring the web map. If we jump to the offline settings in the web map and into the advanced options, we can see down here, we've actually specified the device will use a tile package it already has, and we give that tile package a name, naperville.vtpk. So what that looks like on the device is something like this. Here we have an offline map again, or rather an online map that's been configured with that Naperville VTPK in its advanced settings. And now when I take this offline, you can see in the jobs here, it's only started one job. Ordinarily, it would start two jobs, one for the base map and one for the operational tasks. If you were in our earlier session, you would see that. In this case, it's just creating the geodatabase of the operational data. It knows that it can skip pulling the base map component down because the web map has been configured that way. So in a second here, it will download the data, and now we have our offline map. We can see just the operational data for the area we looked at, but if I zoom out, we can see I've got this entire Naperville vector tile package here that could cover my work day to day. So let's see what that looks like in code. We begin by specifying an area of interest that we want to take offline. We use our offline task that was initialized against the online web map, and we generate offline map parameters with that area of interest. We jump in to creating the job that generates that offline map. Before we do that, we take those parameters we just got and we set the reference basemap directory. Now in this case, it's going to be bundled with the application. We can see up here, we've got a Naperville VTPK file included in this app that I've built. And so this is just telling the runtime, you can find it at this location. And from that point on, everything else is exactly the same. Runtime goes ahead, generates the offline map job, runs that job, and when it's finished, we have a map using the local VTPK that was configured, as well as the operational data that was downloaded on demand.
Okay, thank you, Nick. That's a good demo illustrating the power of this basemaps by reference workflow. And you really saw how much things are sped up by making use of a basemap that's already on the device that we just don't need to download again every time. Another way we can think about optimizing data ahead of time is by thinking about the shape of our study area. So here we've got an example of using Polygon map areas. And again, this is something that is worth thinking about for either the on-demand or the pre-planned workflow. And really this is a very powerful technique because it allows us to optimize by selecting the base map and operational data that we want or need. It can really have significant data savings for linear features such as road corridors or for utility lines. Anything that's a long linear feature, if you can really hone in so that the data you're taking offline just kind of bounds that corridor that you're interested in, it means you can cut out all of that erroneous data that would normally be in the envelope of the feature. And this is possible using the online map area tool with ArcGIS Online. You can also set it up using the REST API for defining your map areas. It's also something you can do with an on-demand workflow by supplying a polygon for your area of interest. So it's a very powerful way of selecting just the area from the base map and the feature set that you are interested in. But you've got to be aware that any edits you make must also satisfy that polygon shape to be accepted. So just like with all sync workflows really, if you were to start adding data that's outside the area of the replica that we created, in this case the polygon for the map area, that would be rejected by the server when you come to sync back. So I'm going to hand you back to Nick for a quick demonstration of working with polygon map areas.
When we first introduced offline capabilities with the runtime, the only way to specify an area to take offline was to specify an envelope, a large rectangle. For many use cases, that involves taking offline a lot of data that you wouldn't ordinarily need just to support the small area within that envelope that you're working with. We've introduced the capability to specify a polygon to take your map offline. And let's look at what that looks like and what an impact it can have for you. So here we've gone to our offline settings for a map that covers some California highways. Now, if we jump into the areas here, you'll see two distinct areas. There's this red highlighted outline of a polygon buffer, and there is the blue highlighted full extent. Now, when we look at the difference in size between the packages that are generated, the full extent generates a package of almost 100 megabytes to download, including the roadside data and the vector tile base maps. When we compare that to the polygon buffer, we've only got 33 megabytes to download. You can see that's about a third the size. It's a big difference. And if you're working on even larger areas with more dense data than this, the impact will be even greater.
Thanks, Nick. That was a quick look at polygon map areas as an optimization strategy. I'm going to have a look now at the two main workflows for our offline map work within Runtime. And these both have strengths and weaknesses when we talk about optimizing our data. So the first workflow is the on-demand workflow. This is where it's all driven by the end user, by the Runtime app. When it's time to go offline, you supply the area of interest that you want to take offline, and we request that offline area from all of the services that make up the web map. So that would be requests sent to the base map, maybe it's a vector tile server or a tile server. And the same for feature data. We create a mobile geodatabase for the area of interest that you've requested. So that can be a very productive authoring experience. It's very quick to set up. All the web map author needs to do is define their web map with the layers that they want to be available for offline use. And they just have to adjust a few settings to make sure that offline use is supported. So as an example, a feature service would have to support sync so that we could create a mobile replica for the local geodatabase. And because of that, this workflow supports editing, supports data editing, and that's a major workflow for offline maps. So you can request your area, take it offline, perform editing, and then sync the changes back. But this workflow does have performance impacts that you really need to take into account, particularly when there are a large number of users planning to go offline. And even more so when those users tend to go offline around the same time. So as an example, if you had a large organization with lots of users who would all try to take a map offline at the start of the workday, you could imagine that suddenly there's a huge spike in the number of requests to the backing services to create these offline packages. So there'd be requests going to create the base map and to create the mobile geodatabase replicas and so on. And if all these things are hitting the server around about the same time, it can really have an impact on performance and it can form a bit of a bottleneck to your workflow. That's not something you want at the start of the day. So as an alternative, we also have the pre-planned workflow. Very similar in concept. You're creating an offline map that you're going to take onto your device with Runtime. But the difference here is instead of requesting a specific area when you come to go offline, what we do here is that ahead of time, the map author or an administrator for the organization identifies map areas that should be prepared to go offline whenever they're needed. So ahead of time, the map author can identify those areas of interest and submit the requests to the feature services then and there. And that means that all the packages that go to make up the offline map for each of these map areas can be created and cached on the server ahead of time. So when a runtime user comes to take a given map area offline, they simply select the area they're interested in and download it. There's no traffic sent to the backing server at all. It's simply a download operation. So it's, again, a really productive authoring experience. It's quick to set up the web map. And defining those map areas is very quick. There's nice GUI tools in ArcGIS Online that would allow you to author these. So there's a small amount of upfront cost for defining your offline areas, but it's very worthwhile in terms of saving that time when you come to actually take the data offline. Again, this workflow supports editing because it uses exactly the same sync framework as the on-demand workflow. It's just that those geodatabases are initially created ahead of time. If you were to do all of the work to create the pre-planned areas that are really quiet time for your organization, so that even could be automated to happen overnight, all of the heavy lifting is done ahead of time when people come to take stuff offline. There are a couple of plus and minus points on this last bullet point. So the field areas are restricted to the map areas that were identified by your administrator. So you could think of that as a plus. It means you don't allow users to sort of arbitrarily take areas offline. They're quite tied into work that's been planned and laid out. That can be beneficial. On the other hand, if your work is quite reactive in nature and you need to be able to very quickly take off an offline map that is unexpected, then that doesn't work with this workflow so well. So it can come down to the geographic area that you're covering. If it's a very large area with lots of unexpected, unplanned work, then the on-demand workflow might work better. And there's nothing to stop you having a combination of these two workflows if that suits best. The scheduled updates workflow is an optimization upon that pre-planned workflow that we talked about on the last slide. And this only works in read-only use cases, so this is not something you can do with an editable offline map. Again, it's a configuration that's set up by the map author ahead of time. The general principle is exactly the same. We have our web map with a number of map areas that have been identified ahead of time. That map can be taken offline as normal. The feature data in the map areas comes from a feature service as normal. And the first time that you come to take the map offline, you would just download it as normal. But it's what happens next is where the optimization kicks in, because you're able to set up a regular schedule to perform updates on the feature data. So this could be hourly or daily or weekly, whatever works with the cadence of your data. And what happens on that schedule is the geodatabases that are part of these map areas in the web map will be updated with the latest changes in the feature service. So other changes that have been made by other users across the organization. But those changes that are applied are not only applied to the geodatabase, they're actually cached as small change sets, kind of delta files that just represent the changes that have happened since you last updated the database. So that means when you come to sync your offline map, we don't have to download the whole area again and the whole geodatabase again. We can simply take those very small change files and apply them into the local offline map copy to get you up to date with the latest state of the map area itself. And this is highly scalable. Many users can download all of those changes at the same time with almost no overload, and it's extremely quick. So I'm going to hand you over to Nick for a quick demonstration of the scheduled updates workflow to see this in action.
So let's take a look at scheduled updates. We'll start with what it takes to configure scheduled updates on your map. So here we have that same map again. It's configured for offline. It has 5 available map areas. We're going to jump in, look at these areas, and take a look at the configuration for one of them. Now, when we create these areas, by default, it'll just package them up afresh every so often according to the schedule, here every week at 1:21 p.m. If we enable scheduled updates, what the runtime will do is it will still generate that package, but it'll also generate a tiny delta package of only the changes to the data that have applied since the last package was updated. You can imagine we could do this every day. And so we'd have a tiny delta representing every day and a map package sitting there waiting for somebody who hasn't already downloaded it so they can get the current state. So all these things are sitting there on the server generated by ArcGIS Online or ArcGIS Enterprise. Let's take a look at what that looks like when it's being downloaded by an application. So here we have an iOS application. We can see here in the middle there's an area that doesn't have any data on it at the moment. I happen to know that when I pull the scheduled updates down for this offline pre-planned map that we have on the device, it'll fill in some data there. So I'm just going to tap on the map to kick that off. Now, the first thing that happens is we find out how much these deltas would, how large these deltas would be if we wanted to download them. Yes, I do want to apply these. So we go ahead, download them, and apply them very quickly. You notice how fast that was. We didn't pull down the base maps. We didn't pull down the entire package. We only pulled down these two deltas that represent the changes that have happened since I got the original map downloaded. And then we apply them in sequence and bring our data up to date. If we look at this in code and see what's happening, it's really straightforward. We take that offline map sync task again, initialize it with our local map, that's the pre-planned map we previously downloaded, and we check for updates. Now, we find out that there's some available, and we can find out how much space they'll take, how large they are to download. So here I just pop up that alert that asks the user if they want to download, and of course I did. And we jump in here, get the default offline map sync parameters, and we just call offline map sync job.start. What this does is it goes ahead, downloads each of those Delta packages, applies them in turn, and comes back when it's finished. There's really nothing for us to do. There's one exception to that, though. Under some circumstances, the runtime will decide that it's actually more efficient to download the latest packaged up entire package and replace what's on the device already with that latest version. That can happen under two circumstances. The first is if the deltas actually turn out to be larger than the latest package that's sitting there on the server waiting, or if that breadcrumb of deltas from the last time that you downloaded the package to the device to today is broken in some way. By default, the server, ArcGIS Online and ArcGIS Enterprise, will keep 5 days worth of deltas. So if the last time you downloaded a package was, say, 7 days ago, and there are deltas missing in between, Runtime will figure out, well, actually, I can't bring you up to date with the deltas that I can download. I'll just download the latest package. And in that case, we have a flag here on the result that's returned to us that says you actually need to reopen this mobile map package. And in that case, we just close what we had already and we load the new one, and the runtime takes care of everything else.
Thanks, Nick. Good demonstration of the scheduled updates workflow there. We're going to move on now to have a look at some of the API options you can use to optimize and control your offline workflows. And the first example we're going to look at here is the API for overriding the on-demand workflow, the generate offline map workflow that uses overrides. These are a set of API options that give you extremely fine-grained control over how a map will be taken offline. They allow you to adjust settings for parameters that address the individual layers and services that you are taking offline. So they give you options for all of those individual settings that you get if you're working for those underlying services. And because you're changing those at runtime, they only work with the on-demand workflow. In the pre-planned case, all of those options and settings have been determined by the web map author when the map area was originally created. So it's only available with the on-demand workflow. It's a fairly straightforward programming pattern. So we're going to take a look at that. On the next slide, we have a basic rundown of the programming pattern. And it works like this. You begin with your offline map task, and we're going to start working with our simple parameters, our generate offline map parameters. You can create those by calling a method that lets you create the default parameters. You should always start there because the default parameters reflect the settings that the web map author has configured when they set up your map for offline use. So that means they've set sensible default values for things like attachments, whether you would be taking just the schema of feature tables, feature layers, and so on. So a whole set of default parameters that are a great place for you to start for a good default experience. But then you can adjust them as required. So you can change all of those settings on the generate offline map parameters, and that gives you enough control for 90% of the use cases that you'll encounter. But if you need further control, if you need this fine-grained control that we're talking about, you can adjust those parameters by creating a set of generate offline map parameter overrides. And they allow you to adjust all of the underlying parameters for individual services. For each of the services in your map, you would have access to the underlying parameters. So when you're working with feature layers or feature tables, you would be working with generate geodatabase parameters. These are the parameters that will be used when we're creating a mobile geodatabase. If the service is a vector tile service and we're going to be exporting a vector tile cache, you can make changes to and export vector tiles parameters. And likewise, if maybe your base map is imagery and you're going to be exporting a tile package, then you would make changes to the underlying export tile cache parameters. So you create your basic generate offline map parameters, adjust them. You use those to create a set of generate offline map parameter overrides. You tweak the parameters for each individual service, and then you simply pass those to create a generate offline map job as normal and run it to completion. And from that point on, it operates exactly like the normal workflow. We've added a new option in the last release of Runtime that allows you to choose whether you want to include online only layers in the map that you take offline. Now, this is a new option because in the past, when you take a map offline, it's been guaranteed that it will work entirely offline. All of the data is downloaded to the device, and you can be sure that it's all going to be there and work when you have no network connection. And that's still the primary use case for an offline workflow. So that's the default, to exclude online only data. But there are some scenarios where you may want to leave some of the data online. That might be because it changes very frequently, for example, weather or traffic. And in that case, you really need live data. It's not critical to my business workflow, so I can leave it online. Or it could be some data that's simply too large to take offline, basemap for the whole world, for instance. Or it could be data that simply doesn't support going offline, like WFS or WMS layers, for instance. And in that case, you've got the option to leave the data online. So looking at our offline map task here in pseudocode, we create the offline map task from the map, we load it as normal, and we have to wait because this is an asynchronous operation. We would then generate our offline map parameters, we generate the defaults, and we have this enumeration for online only services option. And by default, we're going to exclude services that are online only. So that could be feature services that aren't enabled for sync. That could be WMS layers, for instance, that, as I said, don't support going offline. So if you want to include those in the offline map, you would set this option to include, and you take the map offline as normal. There's no cost for taking this data offline because we're not actually downloading anything. We just include a reference to the online layer. And in your offline map, when you come to use that, when you have a network connection, these layers will load and will be included. And when you don't, they'll simply be ignored. So we're going to take a quick look at the overrides workflow with the API that I mentioned earlier on, and Nick's going to show us how that works.
So here we have a web map. I'm going to take an area of it offline. Zoom into a small area, and I'll just kick off that offline process. You can see here the offline process on demand has kicked off two subjobs, one for the vector tile basemaps and one for the operational data on top. So it's downloading the geodatabase of operational data. It's now downloading the vector tiles, and we have a map on the device. Now you can see here that some of the operational data extends beyond the extent of the base map. Now that's because when we pull data down, if we intend to edit it, we want the full record there. Otherwise, as we edit and post changes back, we could end up corrupting the source data. But what if I wanted enough base map to cover that area as well? So what I can do is I can provide some overrides. Here I'm going to run it again, but this time I'm specifying an additional override to expand the area of the base map. Okay, so now we can see that same operational data extended beyond the area of interest, but we have an even larger area of base map that's been clipped and brought down. So when we look at the code, it looks a little bit like this. We start off by creating our offline map task pointing at the online web map. And we get some parameters to take that offline given the area of interest. The next bit we do is we generate some overrides. So given these broad parameters, we want to get very fine-grained parameters that we can configure and tweak precisely to our needs. So this is layer by layer, property by property, how we want to pull that information offline. So we provide the parameters to this generate offline map parameters overrides function, and that comes back with these fine-grained overrides that we can tweak bit by bit. So we find a key into the overrides for the particular base map layer that we're after. And we've got a buffered area of interest where we take the original area of interest and use the geometry engine to just expand it by a bit. Then in the overrides, we update the area of interest for the particular key, either for tile cache or for vector tile cache, because we don't know necessarily what the web map has, so we're just being safe here, and we specify that larger buffered area of interest. When we're done with that, we just jump down, create ourselves a job in the usual way, only we call the generate offline map job call that also takes these overrides on top of the parameters. And we start the job, and runtime handles the rest.
Thank you, Nick, for showing us the overrides with the API. So we looked at the overrides, which is a really good option using the offline map task. And it gives you that fine-grained control for the individual services. Now, the offline map task is a pattern that's quite high level in runtime, and it works in terms of the whole web map. It's simple, it's powerful. In most cases, it will just work for taking your map offline. If you need even finer grained control over taking just individual services offline, maybe you don't need the whole map to come offline, or maybe you're working without a web map and you just want to download a specific service for tiles or for geodatabase, then Runtime also offers the opportunity to work with those individual services. And you can pick a specific service depending on the type, a specific task depending on the type of service that you're working with. So when you're wanting to download imagery tiles as a TPK or TPKX, you can use the export tile cache task. When you want to download a vector tile package, and also you can bring down custom styles and those style resources for the vector tiles, then you'd use the export vector tiles task. If you're bringing down a mobile geodatabase, which is a SQLite format, then you would use the geodatabase sync task, and that would be something that you would use with an online feature service. So these three task types, I'll let you bring down individual data packages for their specific service types. At a high level, they work quite similarly to the offline map task. You're going to load the task with the underlying service URL that you're interested in. You create a set of parameters that let you control how the data should be downloaded. Then you use those parameters to create a job, which is run as an asynchronous operation. And once it's complete, you'll have access to the resources on your device. There are some other data reduction strategies you can take advantage of with Runtime. When we are thinking about feature data, one of the big things is how the data is required for your workflow. Now, if your workflow is really just capturing new data, then you might decide that your users actually don't need access to other data that's been captured previously. So in that case, there's no need to download all of the information from previous site visits, and you could just bring down the schema, which is all that your users will need to add new data for the area that they're working in. When you come to upload your data, it'll just get added to the online feature service, but on your device, you don't need access to all of those other pre-existing features. The same could hold for attachments. Maybe when you download existing features, you just need them for context. You're not going to be examining previous attachments. So, for example, photographs from previous site visits. Now, attachments obviously can be quite a large amount of data to download. So if by default you set your service to not download attachments, it can save a lot of download traffic. Likewise, you can apply a definition query to reduce the information that gets downloaded. So for example, if you're only interested in working with features that have an attribute in progress, or to tell you that the work needs to be carried out, you can apply a definition query to the service before you download the data. And that's going to greatly cut out any features that aren't relevant to be downloaded. You do need to be aware that any edits that you make must also satisfy that query to be pushed back up. So for instance, if you have a definition query that limits the features that you download, you can't then edit features so they no longer meet that definition query and sync them back to the service, because the replica that you're using has been generated with that definition query, and it will only accept features that also fit that definition query. For vector tiles, and specifically for the Esri export, Esri vector tile base maps, one of the things that you download when you take those services offline are resources including fonts. And these have to support fonts for all the different locales and character sets that are found right across the base maps. That's quite a large download potentially, and it's not something that is required for all base maps and for all areas. So Esri also publish a set of for export versions of those vector tile services that have reduced font sets. That means that they have a much smaller download footprint, but it's worth being aware that they don't work for all character sets and in all areas. If your use case doesn't require characters in other font sets such as Chinese or Japanese or Thai, then this might be a good fit for you. The important thing is to test what the data is going to look like in your area of interest. If you're happy that it is suitable for your use case, then you can author the web map to use the for export version of the vector tile services. Runtime also now has an option that would let you switch to the reduced font version of the services, and you could use that provided you're happy that the coverage works for your area of interest. Okay, so that was looking at some of the API options for working with offline data. Let's turn now to considering working with version data, because this is quite an important topic, particularly for editing workflows, which are a major use case for offline work with Runtime. Typically, when you perform a local edit and sync with Runtime, the edits are just applied directly back to the feature service. And the rule is that it's last in wins. So if you had two users performing edits on the same data, the last one to sync it's their edit that sticks. If you need to support a model with multiple versions, that's possible, but it means a more complex workflow on the back end, really, because you're going to have multiple versions that need to be dealt with via a reconcile and post process. Typically, the complexity won't show up for the user of Runtime, for the end user making the edits, but there is a process that needs to be followed on the server itself. So let's take a look at working with version data. Let's take a look at working with traditional versioning on ArcGIS Enterprise. Now there's two versioning models with ArcGIS Enterprise. We have traditional versioning, which we'll look at first, and there's a newer branch versioning model, which is used by, for example, utility networks. So within traditional versioning, there's two workflows. We have the default, which involves creating a new version per map that's taken offline. And we have the other option, which is creating a new version for every user who's going to be using your feature service. So there's great online documentation that you can consult for this that goes into loads of detail about the different workflows and the pros and cons of each. So begin with the default behavior, which is to create a new version per map. So in this scenario, in this workflow, a new version is created every single time a map is taken offline. And the edits made to that offline map will be synchronized back to that specific version. One of the main benefits here is that your offline map always takes the latest changes from the published map, from the latest state of the main line of the feature service. So you know that when you go offline, you've got the most up-to-date information. The version gets created with a unique identifier, and that's built up from the user ID, the name of the feature service, and then a unique number to guarantee uniqueness there. With that version, once edits are complete, you have to perform an additional reconcile and post on the server to bring those changes back into the system. So this approach is really good for a quick offline editing session, maybe for a few hours or for a day or two. So use cases like data maintenance, field inspections and stuff, it works well here. It wouldn't be so good for workflows where the offline map is expected to be checked out, if you like, for weeks at a time. And the other thing to consider here is that every time any user takes a map offline, they create a new version. So if you have a lot of users, you're potentially creating many versions every time they take a map offline. They're creating a new version. So there can be quite a maintenance burden. Let's take a look at this in a visual form. So for our feature service here, we have our default version, and that is used as a feature service in a given web map. Now, we want to take that web map offline, and we're going to do that with, in this example, Bob's collector for ArcGIS. So this is the client that's going to take the web map offline. So when we do that, we get our local copy, the map offline, and that's based off this network that's specific, sorry, this version that's specific for that offline map. So here it's named after the user, Bob, then the feature service name, netfs, and then the unique identifier. And that version has come straight off default, so we know it's got the latest set of changes. We can make some edits in our local copy of the web map. Then we come to sync them back, and they go into that unique version. And then once work is completed with the offline map, the final stage is to reconcile and post those edits back into the default version. And then at that point, we're possibly done with the Bob netfs 14 version, and it can be dealt with. Okay, let's take a look at the second workflow available with the traditional versioning model, and that's to have a version per user within the organization. So here we create a new version for each person who's taking this map offline. And there could be multiple downloads by the same user on different devices, and they all get the same version. So the same user can work across devices and be confidently using the same version. It's not guaranteed to retrieve the latest data from the published map, because you're always going back to that version for the user. So without backend work to keep that version up to date with the mainline, you're possibly not getting the latest version of the data. The version name here is based off the user ID and then the feature service. But as we mentioned, there's an additional reconcile and post process that's required to take the changes from the user's version and update them to the mainline, but also to bring the changes down into the user's version so that they can benefit from those as well. And this kind of approach is good for slightly longer duration fieldwork, so it could be days to a week or two. Users can work away in their version to build up all their changes until everything's ready to be brought back in. So let's take a look at this in a graphical form. In this case, we've got our default version for the feature service, and we're going to use a version for inspections. So all the inspections are going to be happening against this version. And so we create a web map that's specifically for this inspection project. Now when another user, Joe, comes to take the inspections web map offline, he is going to get access to his specific version. And you see here we've got Joe inspection feature service, which is his specific version. And that's always the one that he'll get when he takes it offline. Another user, Mary, again, comes to take that inspection web map offline, and a specific version will be used here. Again, Mary inspection feature service. Now, these two users can begin editing and syncing, and their sync process will target the specific version that's created for their user. So you see here Joe's changes go into his version. Same would happen with Mary's. But those changes haven't made their way back to the mainline yet. So to achieve that, we need to do reconcile and post. And in this case, because we're using that inspection version, both Joe and Mary's changes are being reconciled and posted back to the inspection version. That means that they can get access to each other's changes, and when they sync, they'll start to show up on the local offline map version as well. And finally, once the inspection project is complete, we have to do that further reconcile and post to take all of the inspection details back to the default version. Okay, let's take a brief look at the other versioning model that's available with Runtime. This is the branch versioning, the newer versioning model, which has been designed really specifically with the WebGIS model in mind. It differs from traditional version in that you must be collected to the default version. The offline data uses a simple feature model, but there is an overhead here because edits that are made in the field create dirty areas that must be validated with ArcGIS Pro before they can be brought into the main system. The approach does scale really well to a larger number of editors, and certainly more so than the traditional versioning models. And as I said, this versioning model works well for utility networks and workflows such as that. So let's move on to think a little bit about strategies you can consider with the sync framework. You really need to think about sync. There's a default approach which will work, but it doesn't mean it's necessarily the right approach for your workflow. And really something you need to think about as the amount of offline work scales to more users and more sync operations. So let's take a look at the overall flow in a graphical form. We begin with our sync-enabled feature service. When we want to take that offline, we generate a geodatabase, a mobile geodatabase, which is enabled for sync. We can then take that geodatabase and we can make adds, edits, and deletes using Runtime APIs. When we're done with our edits, we call sync, and that's going to create a geodatabase delta, which contains just the changes I've made, my edits, and prepare them for upload to the server. So we create this upload delta and send that back to the feature service. So now my edits have been taken back up to the feature service. If there's any edits from the feature service, maybe other users have pushed their changes, and we want to download them to my local copy, then we have to retrieve a response for that. And again, we have our download delta in this case with that change set, and then we can apply that response to the local geodatabase. So that's the overall flow, which will allow my local changes to sync up and other users' edits to be brought down to my geodatabase. That's the full flow of data through the system. But the important note here is that you don't always need to do it all, and you can selectively think about the parts of the process that you want to build into your workflow to try and get the best performance. So the full sync approach that we just saw laid out in that slide and the default approach is a bidirectional sync. That means that changes on the client are sent to the server, and any changes on the server are sent back down to the client. As I said, that's the default. It will guarantee all of the information gets to both places, but it does perform the most work, and it has a performance cost. If you, instead of taking a bidirectional sync, you think about one-way syncs, we have two options here. We have the upload from the client, so that's taking the local edits that I've made in my mobile geodatabase and sending them back to the server. That's quite a lightweight operation. That does not have a severe performance hit on the server itself. On the other side, if I was to do a one-way download from the client, that is a heavyweight operation. This is where I want to get all the changes from other users. But to prepare the change set that's required for my specific replica of the server, it's a heavyweight operation because it requires a unique lock on the server's database. So that means that other processes can't be going on at the same time. So if you have multiple users all wanting to download changes from the client at the same time, that's when you start getting into performance problems. And this could easily be the case if you think of a kind of typical workday where all the users go out into the field at the start of the day, perform their changes, come back at the end of the day, upload their changes. That's fine. There's no cost associated there. But if they also all perform a download sync to get the most up-to-date changes for their offline map, then each one of those is going to require a unique lock, and that will slow everything down. So it's a good idea to try and factor one-way syncs into your daily workflows. A good way to think about that is by taking an approach that uses the pre-planned workflow. So that generates a set of replicas for a map area on a regular basis, could be every day. So that at the start of the day, users can simply download the latest version of that map area. There's no unique lock required for each of those downloads because everything has been generated ahead of time. And then at the end of the day, users can simply upload their changes from their map area. And then tomorrow, they're just going to take the map area offline fresh again. So that's quite a nice approach for streamlining that editing workflow. If you've got a non-editing workflow, but you do need access to the latest changes, then we talked earlier about the scheduled updates workflow. And that helps here as well because all of the changes that we need to keep accumulating from the feature server are performed once and stashed for users of the scheduled updates workflow to download and apply to their client. Alternatively, if you know that your offline map is a one-time only use case and you're never going to have to sync, you never want to make any edits that you push back, and you never need to get another set of changes from the server, then what you can actually do is you can use the API to say that your sync model is none. You're never going to upload and you're never going to download. And the benefit here is that it stops the feature server from having to create a replica for your offline map. That's because it knows it never has to deal with any changes. And that's good as well because it means there's no post cleanup operation that you need to do to deal with these replicas that you've created in the other models. Okay, let's take a quick look at data encryption. This is a question we quite often get asked about. Is there built-in data encryption for runtime? And the answer is no. Currently, there's no built-in data encryption at rest for runtime and data. But this is a question that comes up frequently, and it is a research area. Advice would be make sure your devices have locking enabled with a passcode or so on, and ensure that the disk is encrypted as well. And if data security is a really major concern for your organization, then you should consider a mobile device management or MDM solution to give you that extra level of protection. A few other considerations to note. We talked a lot about editing and syncing workflows and so on. Don't forget that you need to clean up your data on completion of your offline workflow. One thing that you may want to do is remove files from your device, delete the packages and so on. To do that, sometimes you need to release file handles. So there is a close API within Runtime to close geodatabases and mobile maps and so on. On the feature service side, every time we create a replica of a mobile geodatabase, we need to make a replica on the feature server as well so that it can track changes to that mobile geodatabase. So when you're done with your version, with your replica, it's important to unregister the geodatabase. And again, there's an API call there, and that allows the feature service to forget about that replica. For troubleshooting, we have a number of error messages that will tell you what's going on or what happened with the job. But for really detailed messages, you can start to see the information sent back from servers and so on. It's a good idea to save out the JSON representation of a job. That'll give you access to all of the messages, and often there's information in there that can help you to understand what's going wrong and to help with troubleshooting. So that's been a quick look at some optimization strategies for working with the Runtime API for offline workflows. And there was another couple of sessions that were in this topic as well, which I hope you found useful. We had one working with maps online and offline, and we had one working with editing data offline. Thanks for taking the time to listen today. I hope there's been some useful information in today's session that you can maybe make use of in some of your own workflows.
Great. Well, thanks for listening, everyone. I'm Nick Furness. I'm a product manager for the Runtime SDKs, and with me is Luke Smallwood, the product owner for the offline capabilities of the runtimes. We've got some really great questions in the chat. I'll admit right now we won't have time to go through them all, so anything we don't get to, please come and find me at the Ask the Experts Runtime SDKs section, and we'll make sure we get you squared away. So let's start off with what strategies would you recommend for generating offline basemap packages, in particular high-res imagery for regions on the order of, say, 100 square miles? Downloads will be infrequent and could possibly be side-loaded. So I'll take a stab at this, and Luke, you can fill in any gaps for me. I think a good strategy. Remember, these are all REST-based services, so a good strategy is actually to maybe even use the Python API. And I would probably break it down into smaller chunks. If you can sideload them, that's great, because if you can pre-process these things, they won't change very often. So create yourself packages using the Python API or the REST API. You could even use the Runtime API and do it with a desktop app, for example, and have these packages available as TPKs or TPKXs, and sideload them according to your needs for your actual app. You can use the estimate call to actually get an idea of the size of the package you're going to get in terms of tiles. And then you can also take a look at the service itself to understand what the tile limitations are. I think it's 100,000 for ArcGIS Online at the moment. With Enterprise, you can tweak that. But that's probably how I would approach it if I have especially if you have a lot of different areas that you need to start downloading. Anything else you can think of, Luke?
No, I think that's pretty fair. Just to call out that Esri imagery base maps do have this tile limit when you come in to export tiles. So that's one of the things that you're working against. But it's a very good question, because the base map is typically the biggest payload that you're downloading by a long way. So if you can optimize that somehow by doing it ahead of time, maybe even using Pro to do that and to sideload the data from there, that's great. One other thing to call out is thinking about the levels of detail. So every time you include another level of detail in your base map, it's almost like an exponential increase. There's kind of a quadratic increase in size as you go down to the levels. So an additional level of detail in the base map will cost an awful lot in terms of file size. So consider if you need that. I think that's good.
Cool, thanks, Luke. Next question, can a polygonal area be used to define the download extent of offline data using the on-demand workflow? That's nice and easy, yes, can.
Yep.
Is there a limit to the size of data that can be taken offline or synced back? I think, Luke, you've got this one.
Yeah, so there's no explicit limit to the number of it's really features we're talking about when we're syncing data backwards and forwards. There's no limit imposed on that, but practically speaking, you are going to run up against issues of file upload and download just to do with network traffic. And it's also worth remembering, like we talked about in the session, what load are you putting on the system? So are you doing a lot of download syncs? If so, that requires an exclusive lock. So that's something that you want to try and reduce the frequency that you're doing until it's kind of required. So no absolute limit, but definitely something that you should be aware of. Yep.
I suppose that relates to another question further down. Is there an option to sync the updates from the parent to your database in smaller chunks, right?
Yep.
If there's a failure due to the size, the parent update sync can be executed multiple times until complete. Yeah, there have been some improvements made. I know that we've been able to drastically improve on some Android devices the amount of sync data that can come down to the device. So if you've got a large delta, a lot of changes on the server since you last synced, we handle that way better than we did, I think, just a couple of releases ago, through a SQLite optimization. And I guess that also alludes to the fact, yeah, this is pretty robust, right? If you do a sync of a map and part of it fails and you sync again, we can pick up we can pick up the sync and it'll transparently complete itself. It won't redo what it's already done. So there's a good bit of robustness there. Jumping back up the list, can offline map areas specified in a web map be used in an ArcGIS runtime application that's directly referencing the feature services of the web map as opposed to the web map itself? I'm going to interpret this question one way. I don't know if it's the right, it's what you mean, but sure, you can look at a web map and get its areas, and you'll get a geometry back that defines the area. You could then use that geometry with the generate geodatabase task. Certainly, if you've got a direct pointer to a feature service, whether it's in that web map or not, you can look at the web map's defined areas and use that against the feature service. I don't know, Luke, if you thought that question meant something else.
Well, I suppose it's worth calling out that the map area that you download, it just will contain the mobile geodatabase that points back to the feature service. So if you're looking to get that offline, that's a way to do it. Yeah.
Right. Okay. Yeah. So there's, I guess that's two definitions of the map area then. Like one of them is sort of the metadata definition of what the area is based off the web map, and the other one is the actual downloaded offline map for that area. Yeah. So I'm talking about the former. Luke's talking about the latter.
Yeah.
Will using runtime offline maps be less demanding on device power than using offline maps in Field Map or Collector? No, they use the runtime, so it's exactly the same. exactly the same drain on the system. If you have specific concerns about that, please do come and see me. I might redirect you to the field apps team, but it'd be interesting to understand if you have specific examples of that.
Yeah.
I think one of these got upvoted while I was talking. So is it possible to create an offline package with a routable road network using the Polygon method? If so, what is the suggested workflow?
So no,
well,
no. You need to take your mobile map packages from Pro if you want to have routing available, and then you can't use the Polygon method.
Yeah, we can't hit the ArcGIS platform or ArcGIS Online and just kind of clip out a locator or a routing model at the moment.
Yeah,
unfortunately, much so I'd like to.
Yeah. I think we're out of time, Nick. Sadly.
Oh, we're out of time. I'm sorry. I'm not paying attention to the chat. Yeah, please come by and find us. And thanks very much for stopping by. Sorry to be so abrupt at the end here.
Thanks, everyone.